Hi class, this is Professor Smith. I am doing a movie on angular and linear speed. In this example, we have a cyclist is riding a bicycle whose wheels have a radius of 15 inches. Suppose she is traveling at 20 miles per hour. A useful fact is that 1 mile is equal to 5,280 feet. They want us to find the angular speed of the wheel in radians per minute and also the number of revolutions of the wheel makes per minute. So what we need to do is talk about two types of speed. One is linear speed, and then one is angular speed. Angular speed is how much you rotate per unit time, and linear speed is the distance traveled per unit time. And the formulas for that we used today in class, I'll bring up math type to write down those two formulas. So linear speed is v, and the angular speed is omega. And then the formula for linear speed is given by, oh dearie, I don't know how I did that. The formula for angular speed is r omega, where omega is the angular speed. And the angular speed is how much you rotate per unit time. So these two formulas are going to be useful for us when we're solving these problems. So in our example, we're given that the radius is 15 inches. Using the annotation tool from Zoom, we have that the radius is 15 inches, and then we also know that she is traveling at 20 miles per hour. So we need to recognize what is the information that was given to us. So when they say that the radius is 15 inches, that's giving us the radius. So that's r equal to 15. And then they tell us 20 miles per hour. Is that going to be the linear speed or the angular speed? And you say, well, how would I recognize that? With that angular speed, it's always going to be in revolutions per minute, or the amount it rotates, or revolution per unit time, or the angle that it rotates per unit time. So it's always going to talk about this circular motion. So that's how you know that it's a angular speed. So since this is talking about miles, which is distance covered per unit time, that's going to be our linear speed v. So that's going to let us know that v is equal to 20. And then 15 was in inches, so let's capture that as well. So we're going to use the formula that relates v and omega, and the reason why is because in our particular problem, they're asking us to find the angular speed. So if they're asking us to find the angular speed, we need to find a formula that uses what we're trying to find, which is the angular speed, and then what's given, which was the linear speed. So we're going to use the formula v equals r omega. So I'll pull that back up. So v was 20 miles per hour, r was 15 inches, and omega is what we don't know. We don't know the angular speed. So now what we can do is we can solve for omega. We can divide both sides by 15 inches. So then we have 20 divided by 15 inches times miles per hour. Is going to equal omega. This isn't omega. I think I picked the wrong thing. Here's omega. And so now I have the angular speed, but if we look at the problem, they want us to find the angular speed in a certain unit, and we have here, it's in radians per minute, and we don't have that in terms of our units. So we have miles per inches per hour, and we want radians per minute. So I think, well, goodness, how can I do that? Well, the first thing I think I want to do is tackle this inches and miles. So I know that there's so many feet, pardon me, so many inches in a foot. So I'm going to multiply by that fact. So there's 12 inches in 1 foot. So then I have to ask myself, where should I put the inches? And I notice in my problem here, I have inches in the denominator, so then I want to make sure that my 12 inches is in the numerator. So I'm going to put the 12 inches in the numerator. And then 1 foot. So then I can cancel my inches. But now I have miles and feet. That's not going to help me either. But they gave us in the problem, if we look back to our problem, they said that 1 mile was 5280 feet. So we're going to use that fact to convert this miles per foot situation. So I'm going to multiply by, again, that feet is in the denominator, so I want that 5280 feet to be in the numerator. So 5280 and 1 mile. Also notice I have miles in the numerator, so that's going to also cancel with the miles that's in the denominator from the conversion of 5280 feet per mile. So I can now cancel the miles. I can cancel the feet. So the only unit I have is per hour. And remember that radians was that strange kind of phenomenon. It doesn't really have units. So it is in radians per hour. So now what we're going to do is multiply all those numbers in the numerator to get our number, to get our numerator, and then multiply the numbers in the denominator. Let me clear my drawing so it doesn't look so crazy. So we have 20 in the numerator times 12 times 5,280 divided by 15. And it looks like 15 is the only number in the denominator besides 1. Okay, perfect. And that's going to be radians per hour, or per hour. So we'll go out to the Alex calculator and do the multiplication. All right, so we're going to multiply by the conversion now. So it's in radians per hour, and we need it radians per minute. So I want the hour to be in the numerator, and then I want minutes to be in the denominator. And I think, well, what's the conversion card that I can use? Well, I know that there's 60 minutes in 1 hour, so I'll put 1 hour in the numerator, and then I'll have 60 minutes in the denominator. And now I'll have the right units. So I can cancel the hours. And now I'll have radians per minute. So let's make sure we divide that answer by 60. So I'll go back out to the Alex calculator and then just divide our final answer that we had, where we had it per hour, by 60. So we're going to divide this answer by 60. So if we undo, that's what we should have had, but it should have been times 60. And so when we do that, we're left with the answer of 1408 radians per minute. So I hope this short movie on finding angular speed was helpful. There is a part B, so I'll do that in the next part. So I'll be back for part B.